In this lesson video, we will be looking at some examples where we will apply what we learned in our investigations. Remember, in our investigations, we were looking at what happens when we change the slope and the y-intercept of a linear equation. All right, let's get ready for some examples. Find example 1 in your notes. Example 1 will look like this. Here it says, write the equation of the line shown on the graph. So the quickest, easiest way to do that would be to get the line in slope-intercept form. So I can see the intercept is -4, and the slope looks like we rise 3, run 1, rise 3, run 1, and so slope would be 3. So I'm just going to rewrite this, y equals 3x minus 4. Here we have the equation of the line that is graphed. Now, part B says graph a new line where the y-intercept is increased by 6. So we're going to take this y-intercept now and we're going to increase it by 6 and graph a new line. Well, we just learned in our investigation what's going to happen when we change the y-intercept. Remember, we're going to be shifting the line up or down. So if this was a -4 and I'm going to increase it by 6, it's now going to be a +2. So let's graph that new line. +2 intercept right here, and it's going to have the same slope. That's not changing. So rise 3, run 1. I'm just going to fall 3, back 1, fall 3, back 1. Okay, so here we go. Here is our new line. Remember our original line, I'm going to darken that back up just a little bit, was right here. And if you notice here, when we went from an intercept of -4 up to an intercept of +2, what happened was this line, it literally just shifted up along the y-axis. It just moved whoop, straight up there, and now it's going to cross the y-axis at +2. So when it asks us how was the graph of the line affected, the line shifted 6 units up on the y-axis. And that is because we increased it by 6. So we just made a shift. All right, let's look at example number 2. We're going to change the y-intercept again. Here it says, write the equation of the line shown on the graph. So here's the line. I'm darken it just a little bit so we can see that original line. Okay, we need the y-intercept, which is 3. We're going to need a slope. So if I look here, I can go rise 1, 2, 3, and I run 2, it's left. So -3 halves. My run was 3, or sorry, my rise was 3, run was 2, -3 halves. So here's our equation, y equals -3 halves x plus 3. That is the equation of our line, and we're going to change it. It says we're going to graph a new line where the y-intercept is decreased by 7. So this time we're going to take this y-intercept and we're going to subtract 7. It didn't tell us we're changing the slope. The slope is going to remain the same steepness, but we're going to take +3 here and we're going to take away 7. Well, that's going to give us -4. So here's our new line that we're going to graph. So the intercept, instead of all the way up here at +3, it's now going to be at -4 all the way down here. Same slope. So rise 3 and run 2 to the left. Rise 3, run 2 to the left, and we're just going to draw that new line here. I'm just going to do it in a different color. So before, the intercept was way up here at 3, and now the line literally just shifted downward on the y-axis, and now it's going to cross the y-axis down here at -4. So when it asks us how was the graph of the line affected, it shifted, or we could say it moved 7 units down on the y-axis. And that is because we subtracted 7 to the y-intercept. And that's going to just shift it down. So anytime that I am changing the y-intercept, I'm changing where the line is going to cross the y-axis. I'm just simply shifting it up or down. If I'm adding, I shift up. If I subtract, I shift down. All right, so now let's take a look at what's going to happen when we change slope. Remember, in our investigation, slope affected the steepness of a line. So let's begin by writing the equation of the line shown here. So it looks like we have an intercept down here at -3, and we've got a slope. If I rise 2, run 1, rise 2, run 1, so I got a slope of 2. So y equals 2x minus 3. You can go ahead and write that with me. And then it says we want to graph a new line where the slope is increased by 2. So this time we are changing the slope. So this slope right here is now going to become bigger because we're increasing it by 2. So it's going to be a 4, and then the rest of the equation stays exactly the same. So I'm changing that to a 4. All right, it was at 2 and now it's 4. So the intercept's the same, -3, but this time my rise is going to be 4. 1, 2, 3, 4, and a run of 1. 1, 2, 3, 4, and a run of 1. And then I'm just going to connect those points and draw that line. Now remember my original line here, I should have made that a little bit darker. That one had a slope of 2. The new red line has a slope of 4. Well, I increased the slope. Remember, the bigger the number, the steeper the slope. So how is the graph of the line affected? The slope, the line is steeper. It is steeper. Absolutely. Steeper because I made the slope a bigger number. Bigger the number, the steeper the slope. And we can see that in the graph. Okay, number 4, we're going to adjust the slope again. This time we're going to decrease it. So we're going to begin again with writing the equation of the line that is shown on the graph. Intercept here is 4, so that's easy to write. Our slope is positive. It looks like if I find more points along the line, we got a point here, here, or maybe not there actually, sorry. But we know this is a point. We know this is a point. So rise 1, 2, 3, 4, 1, 2, 3. So I rise 4, I run 3. So it looks like we got a slope of 4/3. So y equals 4/3 x plus 4 is the equation of this line. I'm just going to make it a little bit darker. All right, there it is. Okay, so now we want to graph a new line where the slope is decreased by 1. We want to take this slope and we want to make it a smaller number. Okay, so what is that new slope going to be? Well, if we start with 4/3 and we decrease it by 1, what will that new slope be? Well, minusing 1, in order to do this, I need to have a fraction. And if this denominator is 3, I know 1 is the same thing as 3/3. So 4/3 minus 3/3 is subtracting 1, and that would give us 1/3. So this new slope is going to be 1/3. All right, well, we know that the bigger the number, the steeper the slope. And we're going from a big number and decreasing it. So we're going to have a slope that's not going to be as steep. Let's check it out. Intercept still 4, so start here, but my slope is up 1 to the right 3. Back 1, or sorry, down 1, back 3. And I'm going to connect the points for the red line. Do you see how, being that I took the slope and made it smaller, I'm going to have a line that's less steep? It is less steep. Okay? So we know bigger the number, steeper the slope. Well, if you make the slope a smaller number, the line's going to be not as steep, less steep. Okay. And here on number 5, I'm going to throw in a vocab word that you haven't seen in a while. Let's see if we can apply this next one here. Graph the equation right here. Y equals 1/2 x minus 2. All right, we know the intercept's at -2. We can plot a point there. Our slope is 1/2. So we're going to go up 1 over 2, up 1 over 2. Continue that. I'm going to go down 1, back 2. Just get a whole bunch of points along this line. There we go. Made it in purple. All right, so now it says if the coefficient is increased by 3, what is the new equation of the line? Whoa, coefficient. Hold on. Now, let's think about what we know when it comes to vocab. Remember these vocab terms? If we have an equation, remember the x is the independent variable, the y is the dependent, the constant over here was the n number, or adding or subtracting. Remember, coefficient, co means to come with. So that's the one that comes with the x. So the coefficient would be the number in front of the x, which happens to be the slope. So when it says that the coefficient is increasing by 3, they're talking about this right here. The slope is going to increase by 3. So if the slope is 1/2 and I want to increase it by 3, I would end up with a slope that's now 3.5. But it's easier if our slope is a rise over a run. So if I change this right here to an improper fraction, 3 times 2 is 6, add the 1, it's the same thing as 7/2. Okay, I just rewrote it as an improper fraction. So this would be 7 halves. Okay, and the intercept is going to stay the same at -2. So here is our line. All right, I got the intercept -2 and my slope is 7 halves. 1, 2, 3, 4, 5, 6, 7 over 2. And I'm going to connect those 2 points. Well, take a look here. When we changed the coefficient and increased it by 3, we were actually increasing the slope by 3. That means we have a bigger number for our slope. It was half and now it's 3.5. So doesn't it make sense that being that the slope is bigger, a bigger number, that it's going to be steeper? Absolutely. So we're going to say it is steeper. So here we're just pulling back one of those vocab words we haven't seen in a while, and that was the word coefficient. That's going to mean the slope because the slope's connected to the x. All right, we are ready for number 6. On number 6, we're being asked which of the following would have the steepest slope. We've got a graph, a table, and a pair of points. Okay, so if each one of these makes a line, which one's going to have the steepest slope? Remember, the bigger the number, the steeper the slope. We know how to find the slope of each one of these types of situations. So here with this first one, I'm just going to look at the graph, and you can look at yours in your notes. We just want to find simply the rise over the run. Looks like I rise 2, run 1, rise 2, run 1. So here, the slope equals 2. All right, let's go to the table. On the table, to find the slope, I want change in y over change in x. The change in y looks like it increases 3. Change in x, it increases 2. So the slope here would be 3 halves, which we know that 3 halves, 3 divided by 2, is the same as 1.5. So far, this one is going to be the steepest line because it's the biggest number. Let's go to the last one. In order to find the slope of 2 points, I use the slope formula. Remember how I'm going to subtract, the y's, and then I subtract the x's. Okay, so i's on the y's, subtract them first, -3, subtract 5, and then I've got the x's, 2, subtract 10. Okay, so top I get -8, bottom I get -8, which means here I'm going to have a slope that's equal to +1. Okay, because -8 divided by -8 is 1. So I'm going to compare the 3 slopes, and when I'm comparing them, I know that the steepest slope is going to be the biggest number, which would be 2, so I would pick answer A as having the steepest slope. All right, so just comparing slopes. In number 7, we are asked if the equation right here was shifted 4 units down on the y-axis, what would the new equation be? Well, notice here how all of our answers are in slope-intercept form. When we have an equation that's written in point slope form, we don't know what the y-intercept is. And the y-intercept is what we need to know, especially if we're going to be shifting anything on the y-axis. We need to know, where's this new y-intercept going to be? So I need to take this equation out of point slope form, and I need to put it into slope-intercept form so I can look at the intercept. So we're going to do a conversion. Let's get this equation so that it's y equals mx plus b. All right, so distributive property here, go ahead and do this with me. -1/2 times -8 is positive. 1/2 times 8 is 4, half of 8. Okay, so now I just have to get the y by itself here. I minus the 5. And I get y equals -1/2 x. And then right here, if I have positive 4 minus 5, I have -1. Okay, so this equation that was given to me is exactly the same as this equation. I just simply converted it into a different form. Now let's go back to the question. If the equation was shifted 4 units down on the y-axis, what would the new equation be? Well, if I'm going to shift this equation 4 units down on the y-axis, just like we were doing before, this y-intercept is going to decrease by 4 because I'm shifting it down 4 units. Okay, so then what would this new equation be? Well, let's take a look at a graph real quick. On this graph, I have y equals -1/2 x minus 1. right? I have this equation graphed. Now, if I'm going to shift it 4 units down on the y-axis, that means it's no longer going to cross at -1. I'm going to go 1, 2, 3, 4 units down. It's still going to have the same -1/2 slope, but I'm shifting it down 4 units. Like I'm literally just moving it down. So do you see how it's no longer crossing at -1? Now it's going to cross at -5. Because if I have -1 and I go down 4 units, I then am going to have, well, the same slope, but I'm going to have an intercept of -5 now because of that shift. And you can see that really nicely here in that graph. Okay. So that means that equation B would be the new equation after the shift was made. Okay, so see here we had to change forms to get the y-intercept, to get the information we needed. All right, we are ready for number 8. If you change the slope of this line right here, 8x plus 2y equals 10, if you change the slope of this line to 1/2, how will the graph of the line be affected? Okay, well, we got some choices here. But if we're going to change the slope of this line to 1/2, don't you think we need to know what the slope of this line is? Yeah, absolutely. And when an equation is in standard form, you have no idea what the slope is. You need to convert it. And the quickest, easiest form to convert it into is y equals mx plus b form, because then we can see exactly what the slope is just by looking at it. So let's convert it. So let's go ahead and write the equation. I'm going to write 8x plus 2y equals 10. And we're going to convert this. We're going to solve the equation for y so we can get it into that form. We can see the slope then. So just subtracting the 8x. Over here, let's get these in the right order. -8x plus 10. Now I'm going to divide everything by 2. Slope, intercept, all of it. Okay? Okay, so now here my slope is going to pop out at me. It's -4 and the intercept is 5. Okay, so all I did was I converted this equation into slope-intercept form, because now I can see exactly what the slope is. Now it says that it wants me to change the slope to 1/2. So if I change the slope to 1/2, how is the line going to be affected? Okay, well, we know that changing the slope is going to change the steepness, so it's definitely not going to be D. Okay, changing the slope will change the steepness, and so the steepness will be affected. It can't be C either. It's either going to be steeper or less steep. Now, remember, when you're comparing slopes, ignore the negative and the positive. Just look at the number. Okay, this is a 4 and this is a 1/2. So when I went from a 4 slope down to a 1/2, because my number's smaller, my line is going to be less steep. Remember, the bigger the number, the steeper the line. And so this is going to be a much less steep slope. Even though it's going upward, it's less steep than this big slope going downward. Okay, great one. We got number 8 done, and we are ready for number 9. On number 9, it says, which equation has the steepest slope? Okay, well, slope, all right. All of these are in standard form. Well, we can't tell the slope when an equation is in standard form. So what we're going to need to do is to change each of the equations into this form, y equals mx plus b, so we can actually see what the slope is and compare them. Yes, we know that the bigger the number, the steeper the slope, but what are the slopes? So this one's going to take a little bit of work. All right, let's take a look at this here. I'm going to go back to the slideshow. All right, here's number 9 again. Each one of these equations is going to have to be converted. So I'm going to first start off by converting this first one here. Now, you can pause the video and you can take your time and do this as well. But if I take the equation and rewrite it slope-intercept form, I now have the equation in a form which I can tell the slope here is 5/4. Okay, I'm going to do the same thing for the next one. I'm going to take that equation in standard form, convert it just by solving for y, and I get the slope. All right, doing the same thing for the third one, converting that equation. It's in standard form. I convert it, and I nicely can see the slope. And then the last one, same thing too. I'm going to go ahead and I'm going to solve it for y and convert it, and I get y equals 3/4 x plus 2. Now that I have all of the equations converted into a form which I can compare the slopes, I then can look at all of the slopes to see which one is the biggest number. Steepest slope, biggest number. 5/4, 1/2, 4/5, and 3/4. Well, do you guys see that 5/4 is the only fraction of all of them that's bigger than 1? So that one's going to have the steepest slope because it's the biggest number. All right. So now, summarizing, let's do the summary in your notes. When we change the slope of an equation, it's going to change the steepness. Okay, the bigger the number, the steeper the slope. Doesn't matter if it's positive or negative. The second thing that we investigated was the y-intercept. So when we change the y-intercept of an equation, it's going to move it or shift it up or down on the y-axis because that's where you find the y-intercept, on the y-axis. All right, thank you so much for joining me. I hope that you learned a lot.